In this video we're going to look at the protocols in networking and the domain name system for computer science. So the first protocol we're going to look at is the TCPIP protocol. So what a protocol is a set of rules that we agree to follow when doing something, when attempting a particular action. So TCPIP is a protocol that computers follow to transmit data to one another error-free. So it works on the following ideas: that each computer has got a unique address, files can be split up into smaller files, the computers are capable of acting as a go-between for transmission, that we can check and confirm if a transmission has been completed, and that we can check and request to send a packet when something is missing or could. So there's two transfer protocols. You've got TCP and UDP. So TCP is a lot more accurate than UDP because UDP doesn't have any error checking and handshaking. So when we send something using TCP, there's a thing called a handshake, and every time something's sent, it sends a request back saying success, well done, you've done it. Whereas UDP does not do that. That means it's a lot faster than TCP because it doesn't do this check. So UDP is good for streaming, gaming, voice over IP, things that don't need to be accurate. If you think you're watching a film and you lose a couple of frames because of some transmission error, it's not going to ruin the whole film for you. Whereas TCP is used for emails, sending files, downloading websites, things where things are missing, it wouldn't work very well, or wouldn't work properly. So example, we send a data packet, and then the computer at the end sends a receipt back saying yes, that was sent successfully. Whereas UDP will keep sending packets and send another packet, and even if the packet's lost, it just carries on going, it doesn't stop. Keep sending and keep sending. Now the next protocol we'll look at is the Hypertext Transfer Protocol, or HTTP, which is a set of rules that must be obeyed when we're using the World Wide Web. It also determines how computers can request web pages and how servers respond to those requests. When some form of security is used, this changes to HTTPS. So the S after HTTP, which refers to it being secure. We use a thing called an SSL, or a secure socket layer. Now it is slower to use HTTPS than HTTP, but if you're logging into a website or you're using your banking details and things, you want it to be secure. You don't want someone to be able to intercept a packet and be able to read your data. So the SSL, or the S, adds a layer of encryption. Now URLs, or uniform source locators, are what we recognise as web addresses. So www.google.com is a URL. So what these do is these represent IP addresses, and are used because remembering an IP address would be a pain. If you type a URL to the browser, it translates it into an IP address using a domain name server. If you imagine having to remember all these different IP addresses, you'd never be able to get onto a website. Cookies are small files that are downloaded onto a computer when a website is visited. The file is stored by the computer browser, so the web browser we spoke about in the last video, and can be requested by the website when it is visited by the client. Now cookies provide a variety of functions. Some of them are essential for the working on modern websites. This includes remembering data from one page to another, such as if you open up another tab and go onto the same website, it'll remember your shopping cart. Sometimes it'll automatically log you in, sometimes it'll already have your name filled in, something like that. It allows the website to make a few more decisions on your behalf and put things in to make your life a little bit easier. Now, there is a thing called the TCP/IP 5-layer model, 4-layer model, or the stack. There's lots of different names for them, but it basically encompasses these 4, and depending on the exam board you use, there may be a 5th one in there as well. So you've got different layers. So the first one is the application layer, which contains protocols that know how to package requests to the transport layer. So I would say the application layer is a little bit like the browser you're using, or it's the email client you're using. It's the one that interacts with you, but then it also needs to send requests to the transport layer. So each of these different layers can only talk to, so the application only talks to transport, transport talks to the internet working and the application, and so on. So the transport layer manages the session, which is it sort of establishes a connection and what's called a byte stream, and it sort of decides how they're going to talk to each other. So this layer packet is called a segment or a datagram. Now the internet layer or internet networking layer, this turns data into IP packets and adds the address and information and tells them where they're going to go. It routes those packets. And then the network interface layer is how the data is physically sent. Now sometimes this is also called the physical layer, and it adds the MAC address information, and then packets are usually transported across a thing called a frame. Now some of the protocols that you may have heard of, you've got HTTP, Hypertext Transfer Protocol, which is used for transferring data across a web network. SMTP, Simple Mail Transfer Protocol, sends emails across a network. The Post Office Protocol, used for receiving emails, however it downloads them to the device. Then you've got IMAP, which is the Internet Message Access Protocol, which receives emails from, and you can have them on your computer, your phone, it doesn't download them and keep them on one device. DHCP is Dynamic Host Configuration Protocol, which assigns IP addresses to devices on networks. You've got SNMP, which is Simple Network Management Protocol, which collects and organizes data about devices on a network. You've got RDP, Remote Desktop Protocol, which allows you to connect to another network over a network connection. So it's like me controlling my Office PC at home from school. And you've got FTP, which is the File Transfer Protocol, which sends files over a network. Now, DNS, or Domain Name System, is a way of translating a URL into an IP address. Because it's decentralized, no one DNS server has all of the information, and it comes in a hierarchy which has sort of layers. And in the system, there are clients, DNS resolvers, and domain name servers. Here's an example. You've typed in example.com, and what it'll do is it'll ask your ISP, your local DNS resolver. If it doesn't know the IP address, it'll then ask the servers that are higher up. So it'll ask for the root servers, or it'll ask the com servers, or whatever it is the website you're looking for server. Then what it does is once it's found the IP address, so this one hasn't, but this one has, it then sends it back, and then sends it back to the initial client. But what these computers do as well is they cache where that came from, so if they get asked again, they already know it temporarily. But if they don't use that ever again, then no one ever else wants to go on that website, and then they'll just forget it later on. But I'll talk about that in a moment. Now, I like to think of it a little bit like if you're asking for someone's phone number. So you might go to somebody and say, do you have so-and-so's number, or the IP? But they'll say, no, I don't know, but someone else might do. So they'll go ahead and ask somebody else. They'll say, do you know it? They'll go, nope. And then they ask somebody else themselves who might have the number. And then they'd pass that number and say, yeah, here's a number. And then they'd pass it to the other friend, and then the other friend would pass it back to you. Okay, so that's obviously not 100% accurate, but that's the way that when I was learning these things, how I sort of remembered it, and that sort of stuck with me. So it's like asking a number of your friend and then going, no, I don't have it, but I know Dave does. Dave says, no, I've got all the phone numbers for Class A, but I don't have Class B, so what I'll do is I'll ask so-and-so from Class B, and then Class B says, yeah, I've got all Class B's numbers. Here's Dave's, you send it back. A little bit like that. Now, caching is where if a URL has been translated, it gets saved essentially. So the DNS resolver will cache the result for many different clients to use. So I said it sort of remembers it for a little bit. Also, your computer will also cache the result. So cache results have a time to live and will be deleted. So if nobody else uses it, it's just going to forget it. Now what's good about caching is if you've been on a website once, then it's going to load it a lot faster. If you've already been on it on your computer, it'll just remember it and it won't even bother asking the DNS, it'll just go straight and load the website. If the DNS resolver has the result, then if somebody else goes onto it, it's going to be faster for them because they won't have to ask all of the clients. But when I'm saying faster, it's not going to be a noticeable difference. I don't think it'd be in seconds. And then some scenarios where a DNS won't be used. If you've already been on the website, it's cached, and if you are on an internal intranet, you won't need a DNS. Now, hopefully, you got a lot of all that. You understand about the different protocols, you understand DNS, and what caching and things means. Obviously, if you've struggled in these concepts, please just rewind the video, just watch it again. Look at my animation. It took me a while to do that, so the whole point of making these videos is to make your life a little bit easier and help you revise. So if you enjoyed that, please make sure you subscribe, because I'm going to do the entire syllabus for CIE and lots of other exams. And make sure you like and share it so other people get the opportunity to learn these different bits and bobs. But I will see you in the next video.